All right, so now we're going to be moving down our quadrilateral family tree. We started with quadrilaterals and parallelograms. Now we're going to talk about rectangles. And if you look, you can probably see the way the tree goes. It's going to have the same properties as a quadrilateral and the same properties as a parallelogram. But let's go to our notes, the properties of rectangles, and let's start there. So like I said, it has all 6 properties of a parallelogram. So if we need to make sure we're referencing back. Opposite angles are congruent, opposite sides are parallel, opposite sides are congruent. All of those 6 properties, but these 2 additional ones. So property 2 is that it has 4 right angles. So now it's saying that all of our angles are going to be right angles, which means they add up to, they don't add up to, they are 90 degrees. So if we were to label our rectangle, this is 90, this is 90, this is 90. All 4 of them are 90. Our diagonals are now congruent. Before they just bisected each other, but with our legs being different lengths, we couldn't say that the diagonals were the same. But now we know that when we draw our diagonals, they are all congruent. So when they bisect each other, it creates 2 halves. Okay, so let's do our 2 examples. If JLM is a rectangle, find each missing piece. So it wants to know what's the length of KL. So we have KL. It's an opposite side. Opposite sides are congruent. So if JM is 25, then KL is 25. It wants to know the length of NL. Well, now that our diagonals are congruent, or we also know from parallelogram that they bisect each other. So if this one's 13, then NL is 13. Then it wants to know what is KM. Now it goes back to the actual specific rectangle property that diagonals are congruent. So if this half is 13 and that half is 13, this one is 13 and that one is 13, making the whole thing 26. So let's look at our angles. It wants to know the measure of, I'm running out of colors, KLM. KLM is this angle right here, which because it's a rectangle, they're all 90 degrees. It wants to know the measure of LMK. So LMK is this angle right here. LMK, because it is properties of parallelograms, those sides are parallel. Therefore, the purple line is my transversal, and I have alternate interior angles. So if this angle over here is 68, that means that this angle is 68 degrees. Then it asks for LJM, so LJM, so it's wanting this angle right here. Which is going to be 90 minus 68, which gives it 22 degrees. Okay, 22 degrees. Let's look at example 4. If PQRS is a rectangle, find the measure of angle QPT. So it wants the measure, I'll use a highlighter, QPT. We have alternate interior, so we can say that they are 10x plus 1 is equal to 16x minus 17. If we add 17 and subtract 10, we get 18 is equal to 6x. Therefore, x is equal to 3. It didn't ask us for x. It asked us for this purple angle right here. So if we substitute it in, we get that it's 6. I'm going to substitute in here. So 16 times 3 minus 17. This angle is 31 degrees. So to find the pink one, because they're right angles, is going to be 90 minus 31. We get that the pink angle is equal to 59 degrees. So let's go back to here for just a little bit, because I feel like there might be a little confusion for letter F, how we got LJM, how we got that this one was 22. Well, if we go back to either one of these triangles, the side triangle. If we go back to, say, this triangle right here, we're looking at that one. This is an isosceles triangle, which means that this leg is congruent to that leg. All right, so if we have ourselves this isosceles triangle, where this leg, because the legs are 13, this leg is 13 because the diagonals are congruent. And this angle right here is 68 degrees. That's your base angle. That means that this angle is 68 degrees. Isosceles triangles means that your base angles are both the same. So if there is confusion where that 90 minus 68 came from, that's how I was able to get that other angle.